Hello there. I am a day behind because I took a day off yesterday for NormConf, which was awesome. I hope you were there. I hope you saw it. If not, then why didn't you? But the videos will be up eventually and you can see them then. It was great, but now I'm a day behind on my live coding. So let me see if I can catch up. And if it doesn't take too long today, then I'll just blast through 2 days worth. If it does take too long, then I'll do 1 day's worth and then do the other one, sometime later. So anyway, day 15. You feel the ground rumble again as the distress signal leads you to a large network of tunnels. You don't have time to search them all, but you don't need your packet instead of deployable sensors. You have readily built lost elf sensors are very powerful. That's key. Handle device and see that you're close enough to approach the distress signal. Use it. Pull the signal out, hit the big button, zoom off down the tunnel. Once the sensor finds a spot with a good rating, it attaches itself, begins monitoring for the nearest signal source beacon. Sensor the beacon always has to enter coordinates. Each sensor knows the position. You can determine the position as measured by the Manhattan distance. There is never a tie. It doesn't take long with sensors to report back to their position and close to the beacon. For example, sensor X equals 2, Y equals 18, closest beacon is that. Okay. So consider sensor 218, closest beacon to it. For the sensor closest beacon. Drawing sensors and beacons, the above arrangements of sensors and beacons looks like this. This isn't necessarily a comprehensive map because each sensor only identifies closest beacon. If a sensor detects a beacon, you know there are no other beacons that close or close to that sensor. It could still be beacons that just happen not be the closest beacon to any sensor. So the sensor at 87. Sensor closest beacons at 210. You see none of the known beacons that close or closer. None of the detected beacons seem to be producing the distress signal. You need to report where the distress beacon is by working out where it isn't. For now, just keep things simple by counting the positions where a beacon cannot possibly be just along a single row. So suppose you have an arrangement of beacons like this in the example, and just in the row where Y equals 10, you like to count the number of positions a beacon cannot possibly exist. The coverage from all sensors near that row looks like this. In this example, in the row where Y equals 10, there are 26 places where a beacon cannot contain a beacon. Okay, so let us do this. Okay. From typing import named tuple. And now I can solve a general problem, or I can solve a specific problem. I'm going to solve a specific problem. Class points, which is, you know what, I don't even need to do that. I'll just do point is actually, you know what, I'm going to call it xy, is a tuple of int and int. That's easier. Lowercase tuple. And let's say from data classes, import data class, class sensor, which is a data class, and it is going to have a position and a beacon at xy, and let's make this a static method, and we're going to from string, that's fine. I don't want to do that, do it that way. So let's import RE, and let's say point regex equals x equals I don't know what that px equals, but let's say x equals 0 to 9 plus, comma, y equals 0 to 9 plus. Okay, and that should work. And let's say P1, P2 equals RE find all, I don't want to call this string, what is that name? S. And let's, I don't want to open GitHub Copilot. What is this doing? X1, X2 equals, so that's why I would want to do a named tuple. So I'm typing import named tuple class XY named tuple X and Y int static method from string S string to XY. And now let us say, actually, let me see what this returns. Final point regex S. Okay, so it's going to find yeah, so I don't need to do this. So really what I want to do is I just want to do x1, y1, x2, y2 equals that. And then I want to return yes, so that's good. Why is there parentheses there? Okay. And let's say sensors equals sensor for string. Okay, so let's try that. Run day15.py. Not enough values to pack. Raw dot split lines. Okay, so let's do f equals re dot find all. This is not the part of the problem I want to spend a lot of time on, but print f. And so let's try this. 218. So why did I get? Because there's a possible minus. That is why. Okay, so let's say that's a good catch. And now let's try it again. Okay, and sensors. Okay, good. So now I'm good, and now let's go back to this problem and see. Close the beacon to it. The above arrangements doesn't comprehend the map because each sensor only identifies its closest beacon. The sensor detects a beacon. It could still be a beacon that just happened to be closest beacon to any sensor. Okay. So now def find unallowable columns, which is going to take sensors, which is a list of sensor, and it's going to take a y, which is an int, and it is going to return a set of ints. Okay. For sensors and sensors, x, y equals sensor dot position, bx dy equals sensor.beacon. Okay, and where did closest beacon? And so let's say distance is that, so Manhattan distance, right? So it knew enough to do that. And dist from y equals abs y minus by, or no, I'm using y twice. Find unallowable columns. So I'm going to call this row. Dist from row equals abs y minus row. If dist from row is bigger than dist, continue, okay? And otherwise, so else for dx in remaining equals dist minus dist from row. And now coverage from all sensors near that row looks like this. There are 26 positions. Okay, so here's the deal. Let's say I'm in, here's my sensor, and my closest beacon is here. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So my distance is 9. So I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. So anyway, if I have a row that's 2 away, then I know that there's no beacon from 0, 1, 2, 3, 4, 5, 6, 7, right? So for dx in range remaining plus 1, add x plus dx, return unallowable columns. So I'm not sure that's right. So print find unallowable columns, sensors, and 10. So let's run this and see what happens. We can run too many print statements. Print len of find unallowable column sensors. 27. Is that the right answer? 26. Because we already know minus 1, minus 2, 0, 1, 2, 3, 4. All right, let's do print sensor print x plus dx, x minus dx. So let's run this again. So let's think about this. Sensor position 218, that's fine. Sensor 1214, beacon 1016. So that guy knocks out 12. Let's see if there's an example here. The sensor 87 should knock out, so let's see what happens when we get to the sensor 87. 8, 8, 9, 7, 10, 6, 11, 5, 14, 2. Oh, okay. For delta in dx minus dx, if x plus delta is not equal to bx, no, what I want is if x plus delta rho is not equal to bx by. So if this beacon is there, then that's not an unallowable column, obviously, because now there's 27, and now it has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is 27 right? No, it's still wrong. So let's look at 8, 7. He still does 14, 2 because his beacon is at let's see, 8, 7. Because his beacon is at 2, 10. His beacon is also at 2, 10. Print x plus delta. So, and maybe I forgot to change this. X plus delta. So let's try this one more time. Now it's 26. And now if I go look at it, it skipped 2, which seems to be the right thing. Okay, so let me take that out and take that out. All right, well, let's try it. Okay, so with open day15.text as f, raw equals f.read, sensors equals sensor for string x, that sounds good. Say UC equals find unallowable columns, sensors, and is this number? 2 million. Print UC, print len of UC, and let me change this to assert that this equals 26. I think that's the right answer. 26, yeah. All right. Okay, I don't want to print that. Let me try this one more time. So that took a long time, so that makes me think that part 2 is going to be something that's going to be too slow to brute force. Handheld device indicates there's something being nearby. Just turn a little bit. The position beam must have X and Y coordinates each lower than that. You need to determine its tuning frequency, which can be defined multiplying its X coordinate by 400,000 and adding its Y coordinate. In this example above, the search space is smaller. Instead, the X and Y coordinates can each be at most 20. With this reduced air search area, the only single position can have a beacon. Find the only possible position for the distress beacon. What is its tuning frequency? Okay, so now that's asking you to do too many things, right? That's basically what I said. Stress beacon must have X, Y coordinates for each no lower than 0 and larger than 400,000. To isolate, you need to receive X coordinate and then smaller. Instead, the X and Y coordinates can be at most 20, but this reduced search area is only a single position that could have a beacon. The tuning frequency for this distress beacon is that, right? So we're saying it can be at most 20. So basically you want to find the one square in there that's not covered by anyone, right? So let's think about how we might do that. Like when you have this guy, he takes out a big chunk of them, right? And then you have this guy, and he takes out a big chunk of them as well. And you have this guy, he takes out a big chunk of them as well. So the question is, how do I want to do that? It seems like you want a way of representing basically the unions of these diamonds, right? Because otherwise you have trillions of things to check, and you don't want to check trillions of things. So let's find a faster way to do this. Now that we know both the rows, so like if I look at row 7, from this guy, I know I can basically get an interval, right? So all I need to do is intersect intervals. Okay, so let's play with that for a bit. So instead of let's think about this. So, for here, I've got that, and then some other guy is going to tell me that, these are unallowable. So I actually need to union the intervals, right? And so because let's think about this. Because I can't iterate over each of these. I'm going to have to go beacon by beacon. So each beacon removes a bunch of things, and now I have all these things that are removed, and how do I keep track in a nice way of the things I'm unioning together in a way that's fast. Well, anyway, let me just make this faster now, right? So, because if I can speed this up, then I can just use it again, right? So now, let's say, and let's say an intervals is a tuple int, which is the same thing, but that's okay. And let's say unallowable intervals, which is a list of interval, is this. Okay, and so let's say for sensor and sensors, and let's say low equals x minus remaining. And so let's say if remaining is less than or equal to 0, continue. Remaining is less than 0. Less than 0, continue. Otherwise, low equals x minus remaining, high equals x plus remaining. If low equals, let's say, if low comma row equals bx by, low plus equals 1. Otherwise, if high row equals bx, do I want to do that? I think I do. And if low is less than or equal to high, that sounds good. And now Sure, why not? Okay, so that worked, but it was still slow. But that's good. I don't want to do sets of ranges. And now, so now let me change this to find allowable columns. I think that'll make our life easier. And in x, which is int. What are these all? Is always going to be the same. Okay, so I'll just do this and call it, I want to call it low and high, but I already used this. Roll low, roll low. I'm going to call them A and B. Else if B row, B is already used for something, that's bad, but that's okay. Okay. So now, let me do a couple things. One, let me comment out that part, run it again, see how fast. So that runs super fast. And now what I want to do is I want to print the unallowable intervals and just see what they look like. Okay. And now I want to write a helper function, which is this code is a mess. I hate it, and you hate it too. Find allowable, which is going to have intervals, a list of bad intervals, low, which is an int, high, which is an int, and it is going to return a set of ints. Okay. Bad intervals equals sorted bad intervals. Equals set. Okay, so start equals bad interval 0. If start is bigger than low, out dot then for x in out dot add starts, and there should only be one allowable, right? let's see. Otherwise, why doesn't it like this? Start at 0 is bigger than low. So actually, I'm just going to return int. And so let's say allowable. How do I want to do this? Bad intervals go sorted bad intervals. Okay. That's fine. Else, up to equals start. So now let's say for x, y in bad intervals, if x is bigger than up to, then return up to plus 1, otherwise up to equals max up to plus y. If up to is bigger than or equal to high, return none. I don't know if this is right. Print find allowable, unallowable interviews 020. Yes. Seriously? Because it's down here. So find allowable 2, okay? So oh, 2 is something. No, 2 is it, I think. Okay. So I've got this. and then let's say x equals, there's already an x, so let's say call equals finds allowable, unallowable intervals low high. If call is not none, and let's say row call is not equal to bx by, turn call so okay, so that didn't work. Is 0. So let's say print sensor, print unallowable intervals, and then print call. Okay. Let's run this again. Sensor position 1214, beacon 1216. Is it 1212? So let's look at that. This can't be that fun to watch, can it? Twelve, 14, 12, 14. That's this guy. And then beacon at 1016. Is there, okay? And so his Manhattan distance is 1, 2, 3, 4. So if he goes 1, 2, 3, oh, I think I have my loop wrong. Okay, let's try this again. Twelve, 12, 3, 14. So minus 2, 1, 16, 24, 14, 18, and that is 2. And what I really want is row call not in I don't think I want s dot position. Beacon for sensors. Okay, so let's try this again. Okay, so now I don't really want to print these. We'll call them sensors 2 million, 0, and what is it, 4 million? Find allowable column. Got this right, but they wouldn't just have it work at that particular location. That wouldn't make any sense. Find a beacon sensors, which is a list of sensor, low, which is an int, and high, which is an int. And it's going to return point for I in range, call equals find sensors I, low, high. If call is not none, return I call. I call this XY. Print find beacon sensors 0, 20. $3.15. X equals 14, Y equals 11. Well, that's not right. So, okay, so X equals 14, Y equals 11. That's not even one of the options. All right, this isn't fun. I'm going to take a break.